is going to pay back immediately. I mean, like by having all the information available at the smart grid, there can be software system to reduce the losses or to reduce, I mean, to improve the reliability, availability, all these things. So considering all these things, maybe the price of electricity may not go high, or the quality, again, it has to be compared with the quality of power available, and the availability of power may be all the time 99.99% of time. So all these things can come with the smart grid part. So considering all these things, maybe electricity charge increase may not be there also. Other challenges are the regulation policies to be done by the authorities. Then workforce, maybe the workforce is not available easily right now, but the available workforce need to be trained to bring the smart grid related systems. So let's understand, like, what is the cyber security with respect to the protection relays. Okay, this is a brief background of what it is. Initially, the protection relay was developed in the early years of 1900, and then, like at that time, the electromechanical relays were only available, only developed, and later on, the static electronics relays came into existence in the year of, I mean, in 1960s. The microprocessor based started coming in 1980, and fully numerical relay, including the filtering part, was introduced in 1986. This includes, this is a complete numerical relay. It has the communication feature also, digital communication. Whatever information comes to the relay in terms of voltage or current will be converted it into digital format, and then it will be processed inside, and then it can communicate to the central system also. All the information can communicate to the central system also. So it's very clear that initially, when the electromechanic relays and even the static relays were available, there is no need of protection engineers to understand communication related things, right? Because the relays were not suitable to communicate with any communication, or it cannot be connected to the communication network to communicate with central system, centralized system. So, but nowadays, with the numerical relays, it is very much possible, and it's a requirement also. The data need to be communicated to the central system. So, in this era, it's very important for the protection engineers to understand the digital communication system architecture. This is really important. So, the electrical engineers need to be aware about what are the communication system, what are the protocols, what are the issues related to the communication system. And we know that the one of the main issue with respect to communication is the cyber security. That's a really important issue with respect to the cyber security. So let's discuss a little bit about the protection, like where this communication part comes in the protection, and then we go to the cyber security related to it. So yeah, this slide just to give a brief of what are the types of protection available, like overcurrent protection, earthfall protection, overload protection. So these are based on the current information which is measured by a current transformer. So this is a current transformer. Whatever current measured by the current transformer, based on that, the relay will operate. Like if the current is more than the rated current of this feeder, there is something wrong. So this breaker need to be tripped. So for that, these protections are used. And differential protection is basically to trip one zone of protection. Like if there is a object to be protected, or transmission line or transformer need to be protected, so the differential protection system checks whether the fault is within this zone or outside. If it is within the zone, this relay is going to trip the breakers here and here and isolate the faulted portion. So that's what differential protection is. And the distance protection is basically like it is employed in the transmission lines. mainly, or the cable systems mainly. Based on the impedance, like if the power is flowing from this side to this side without any fault or something like that, then this relay will see some impedance. I mean, by taking the voltage signal and the current signal to the relay, this relay can calculate the impedance measured by whatever current and voltage seen at that point of time. So, but when there is a fault on the transmission lines, then what could happen is that the network is going to be like closing at faulted point itself. So the impedance seen by the relay will be only the impedance of transmission line up to the point of fault. So based on that, the relay will take a decision to trip or not trip. Because if the impedance is high, then that is not going to trip. Maybe this is a loading condition also. But if the impedance is low, lesser than the impedance of transmission line, it's clear that the fault is somewhere on the transmission line. So it's going to trip the breaker. So that's the distance relay. Restrict drive fault protection and other type of protections are there. That's not really important for the communication part. So let's try to understand what is one of the communication, or how the differential protection works. So if there is a system like this and there is a differential protection like this, so when there is no fault, definitely there will be current flow through this, right? Because there will be load at this end, maybe some generation at this end. So the current has to flow through this, through the transmission lines to the load side. So let's assume that the generation is at bus A and load is at bus B. So the current can flow from bus A to bus B through this transmission line. So when the current is flowing like this, then this CT will measure the current and give the information to this relay, and the current CT end B will see the fault at will measure the current at this point and give the information to the same relay. So what can happen is that if the current is flowing in this direction, like from one side going out of the bus, another side going into the bus. So it is like the direction will be just the opposite with respect to the CT. With respect to the CT and with respect to the switch gear, the direction is just the opposite. So one place current is going out of the switch gear or the bus bar. Other place current is coming into the switch gear, like if the current flow is considered in this direction. So when it is measured, it will be something like this. The sinusoidal representation is here. So at current, end A is taken as this orange color. So here, end A current is there. So end B current will be just 180-degree out of shift. I mean, so it will be something like this. So if you add the current at any instant, the total current is going to be zero. Total current is going to be zero. So what this relays does is that it just adds the current at each interval, and then if no current is there, that means whatever current is coming into the system going out through the other side. So the relay is not going to operate. But if there is a fault here, what could happen is that the whatever current comes from the source is going there, it does not go to the other side. So if there is a summation here, maybe one side current is not there and B side current is not there. Whenever this gets added up, so always there is a current, resultant current is there. So that is going to operate the relay, and relay is going to trip this breaker and also this breaker and isolate the faulty portion of the system. So that's how differential protection operates. But what happens if the differential protection need to be employed for a transmission line? Transmission line length could be 100 km long. So definitely the CT secondary current cannot be taken through 50 km long system, because it's a just a signal, 1 amp signal. CT ratio used to be, secondary side used to be 1 amps. So this 1 amps cannot be taken through a 100 km long system, because the CT has its own limitations, saturation effects, and all things are there. So it cannot take such a long distance. So the protection scheme for that system is that they put two relays at one at each end. Then whatever information taken by the relay from one end will be transferred to the other end through the communication channel. It could be a fiber optic channel, or it could be a metallic wire channel, twisted pair, or whatever it is. So whatever information taken, which will be digitized inside the relay, and then the digital information will be transferred to the other end. So that's what is showing here. So the length of the line is more, then this is going to happen. So what could happen here is that again it compares the same way. Like if there is an external fault or normal loading condition, then the current what is measured here and what is measured here will be 180-degree out of shift. So the resultant current will be exactly zero. But if there is a fault inside the zone of protection, then definitely there will be a resultant current which is going to operate the relay. So that's shown here. So how the relay calculates or measures that value is important, because when you employ a communication link, there will be a delay in the communication. I mean, whatever current measured by this relay is instantaneously done without any time difference. But whatever current is measured by this relay is going to be transferred to the other end. So there is a communication delay. It could be few millisecond, 1 or 2 millisecond, but still there is a communication relay. So what relay does is that uh, like local current is actually happening at this point, but whatever current comes from the other side through the communication channel is it's happening. I mean, it reaching to the other end after a time delay. So this is the channel time delay, the communication channel delay. So this is the time at which the relay gets the information from the other end. But local current is already measured at this point. So if you compare this current and this current, definitely there is a resultant current that is going to maloperate the relay, or nuisance operation of the relay can happen. Unnecessary, unwanted tripping of the circuit can happen. So what relays does is that if this channel delay is known, then whatever current measured by the relay locally will be stored, and it will be available after this channel time delay also. And then whatever current measured here is, this is the memorized information. Like the local current is memorized for comparison. So whatever current measured, maybe let's assume that this is 5 milliseconds. So whatever current measured 5 millisecond prior, that will be compared with whatever current available from the other end through the communication channel, which is came through the communication channel. So when this is compared with this current again, the resultant current is going to be zero. Resultant current is going to be zero. So, what is the concern? What is the concern if this channel compensation is not properly done? Okay, actually, the channel time delay was this much up to this point, but due to some error, or maybe somebody hacked into the communication network, then they do something and then increase the time delay. Initially, it was this much, but increase the time delay. Then what could happen is that the memorized information comes here, but actually the other end information comes only at this point. So there is a false signal. When this it gets added up, there is a false signal always. So this false signal is enough for the relay to maloperate. So what could happen is that the relay can issue trip command and isolating the section, but there was no fault at all in the section. So it's going to be a nuisance tripping or unwanted tripping. So it is going to impact the grid if such a tripping happens. So another part is the distance protection, which is also just to tell what is the communication requirement in the protection. I mean, we have discussed about distance protection operate based on the impedance measured by the relay. So what generally done is that 80% of transmission line impedance will be set in, we call it a zone 1 setting, which is going to trip immediately, if there is a fault seen within 80% of the line, the tripping will happen immediately. But if the fault is seen after 80% of the line, then we expect that because of some error, maybe the fault is somewhere on the other next bus bar. So this protection doesn't need to be tripped for a fault on other substation bus bar, or maybe some of the feeders going out of that substation. So its own protection is going to trip for that. So that is why we are time delaying the protection to 0.4 second. Whatever fault comes after 80% of transmission line, that fault is going to be tripped with a delay of 0.4 second, which is common for the other side also. But when we see the other side, again 80% is up to this point, from this point to this point here, and here it is after 80% with the time delay of 0.4 seconds. So whenever there is a fault here, it is okay because it's stripping at 0 second from either side. So no concern. It's tripping correctly, and it's going to have an instantaneous clearing of the fault. But what happens is when the fault is happens immediately after 80% of transmission, or maybe close to the remote end. So what could happen is that this side relay going to see the fault without any time delay, 0 second. But substation A and relay is going to see the fault in zone 2, which is going to trip at 0.4 second. So overall fault clearing is going to happen at 400 millisecond, including the CB operating time, everything together, which takes maybe 100 millisecond additionally. So the total fault clearing time is going to be 500 millisecond with the distance protection without any communication channel. So this is not going to be accepted by the authority. I mean, any transmission line of voltage rating more than 220 kV is going to trip. It has to trip instantaneously for fault anywhere in the transmission system, anywhere in the transmission system. So this cannot be accepted by the transmission authorities. So what is being done for that? We use some communication based scheme. So what happens is that whenever there is a fault here, as we know that this side relay is going to trip within 400 millisecond, and this side relay will trip the relay within not within, I mean, no time, because no intentional time delay is kept for that. So what this additional communication link will do is that whenever zone 1 operation is detected for any side, that is going to be transferred to the other end. And when this signal comes from the other end, which is like informing the relay that okay, there was a fault on zone 1 at the other end, then this side relay is also going to trip immediately. Okay, so which is like the representation here is much easier. So what it does is that we know that zone B relay is going to see the fault on zone 1 because it's within 80% of its reach. So the zone 1 is going to trip. So whatever is red color is like operated, whatever is in black color is not going to not operated at that instant. So this is at the instant of fault. So zone 1 is going to operate from substation B end. So this is going to trip the breaker immediately. So on one operates, it's going to trip the breaker immediately. At the same time, this is the communication channel. The dotted portion is a communication channel. So at the same time, one signal will be sent back to the other end that, okay, there is a zone 1 operation from the other end. So whenever this reaches, either zone 1 operates, or when the signal reaches the zone or the substation end, a relay also going to trip immediately. So only the additional time delay required is this transmission time delay, communication time delay here. So that may be 5 to 10 milliseconds. So uh, we can see that even for a fault here, this is going to trip instantaneously by neglecting that 5 millisecond time delay. So it's going to trip instantaneously. Overall time delay will be 100 milliseconds. So this is in the previous case, overall time delay was 400 milliseconds without communication channel, but with a communication channel, it's going to trip immediately. So this system is called direct transfer trip scheme. There are different trip scheme which is just listed here. It's not important for this training session, just to understand what are the concerns of cyber security with respect to the communication schemes. So the communication aided scheme is definitely increases the response time. I mean, it's going to be faster response. the dependability is increased and security is increased. So communication aided scheme is a must for the modern grid system. This is what we discussed earlier. The grid authorities specify the requirement of instantaneous fault clearance for HV and EHV voltage level, which is especially at 220 kV and more. Definitely, instantaneous fault clearing is a must in order to ensure the stability of the grid system. So, the communication aided scheme is a must for higher kV level. So, other communication requirement in the system is substation automation and SCADA. We all know that major substation is controlled with SCADA systems. So, like all the information at the bay level or the equipment level will be taken through the bay controller unit or the numerical relays in the system to the SCADA server through the communication network. This part is the communication network. So each equipment data from each IEDs, VCU is also an IED, numerical relay is another IED. So all the information will be taken through the communication network to the SCADA server, and the information will be available to the operator stations. So the operator will has the information about the entire system, or operator can give some command for controlling or switching on or switching off of any breaker. And again, that command signal will be going through the communication network to the IEDs, which is a back controller unit or a numerical relay. So back controller unit will take the command from the operator, and then the back controller unit will give an output contact to operate the breaker either close or open. So that is possible. So there's a huge communication network. So cybersecurity is a major concern here. That's another point. And another system is a digital fault recorder, wherein the information will be taken from each and every substation, or maybe we can say each and every circuits, transmission line or transformers. And then right now I have shown only two substations here, but in a network there can be hundreds of substations, and the digital fault recorder systems will be installed at each and every substation, and the current and voltage information from each and every circuits will be taken to the digital fault recorder systems, and that will be transmitted through the communication network to the centralized location, which we call it as master station. So at the master station, the information of voltage current of all the systems are available. So if there is a fault in the system, that fault will be recorded in the recording system local to the substation, and then that information will be transmitted to the master stations through the communication network. So the operator or the maintenance staff can come near the master station, and he can see the voltage and current information, and he can come to conclusion that okay, there is a trip, and the trip is real tripping by seeing the current fault current values, or maybe the trip was there, but there is no considerable change in either voltage of current. So that means the tripping is not genuine tripping. There could be a issue of transmission relays. Maybe the transmission relays issued a trip command without any real fault in the system. So all this information will be much easier for faster restoration of transmission system. If there is a fault here, then the relay will trip, and then operator can see that there was a real fault or not. Then if there is a real fault, then they can take a decision. Operator can take a decision to isolate only this section and energize all the other sections. So that's one thing. Or if the operator or the maintenance staff responsible for this part, maybe a protection staff responsible for this stuff, checks that information of voltage and current and comes up with a conclusion that this is not a real fault, there was an issue in one of the relay. So the operator can take a decision to close this breaker again, by only removing that particular relays from the system, faulty relays. Because generally for the transmission system, two main relays will be there. So even if one is out, the system can be operated with the second unit, so second relay. So the faster restoration can be possible. That's the digital fault recorder systems part. And then yeah, this is one of the main thing with respect to cybersecurity. The phaser measurement units, the current and voltage information will be taken from each and every locations, critical locations, and then it will be taken through the power phaser measurement units, and then it goes to the data concentrator, and then through the firewalls and all, it goes through the internet, and then wherever the data is required to analyze or maybe to monitor those systems, the data will be made available. So there's a communication network comes into the effect. So again, cybersecurity is going to be a big threat of it. So these are the data access requirement for protection engineers: microprocessor based protective relays, and then digital fault recorders, facial measurement units, SCADA system, we talked about it, substation computers. So these are the data access requirements for the protection engineers. So again, how to set the relay? Like in order to have proper operation of the power system, the setting, the protection setting of the relay need to be accurate. So that's important. So, but whenever like if you take the case of modern relay systems, it is not just used for the protection. It is used also for the monitoring, metering, automation, and control. So the same relay is used for uh, protection, monitoring, metering, and automation and control. So that's one of the main issue with respect to cybersecurity, because the same relay is going to be accessed not just by the protection engineers, it is going to be accessed by the monitoring people, or the maintenance, or the metering people, or even the SCADA team, operation team is going to be used using this the same relay or IED, whatever we can call. So what happens is that protection settings are really important, because if there is a wrong setting in the relay, it's going to maloperate. Like if somebody put a setting lesser than the rated operating current of the circuits, what is going to happen is that the relay is going to give a trip command during normal operation of the system itself. So it's going to be nuisance tripping. So the protection setting is really important. So it has to be ensured that the grid authority has to ensure that the protection settings are permitted to be changed only by the protection staff. So that's really important. Even though the device is being used by different parties, metering people or automation people, protection people, so it has to be ensured that the settings are required to be, I mean, settings are changed only by the protection staff. This need to be ensured. So nowadays, the multifunction relays may generate need to extend setting privilege. That's what I said. So maybe in this relay, some of the settings related to protection things, but some other setting may be related to the automation and control. Some other setting can be related to the metering part. So again, the setting change privileges need to be extended to different parties, but it's not a standard practice, or the practice to be followed by the utilities is to avoid avoid giving the privileges to other parties. So maybe only to protection engineers the setting change privileges need to be given. For other parties, need to be contacted. I mean, need to contact the protection engineers or protection department to make any changes in their system, in case it is really important to make the changes. So that's the part related to it. So this is the feature which we talked about it. So password protection is available. Most relays have the ability to do password protection for setting changes, lock for setting changes. That is another thing. So issue an alarm when setting changes has been made. So it can control, like setting changes are not done unnecessarily. So there is an alarm. So the system knows that who has done it, because there can be a camera there. So by seeing the time of the time of this setting changes, it can be easily tracked, like who has done the setting changes. So unnecessary setting changes will not be done if such systems are there. Then different passwords can be like right now the relays has the feature to have different passwords. One password can be for like read-only access for large number of users, but maybe higher level of password for maybe the protection engineers for changing the protection settings. So even though the monitoring people gives an access just to see the relay information data from the relay, like voltage or current information, but they may not have the information about the password for higher level. And only with the higher level password, the protection engineer can change the protection settings. So other parties cannot do the setting change. So this is the feature available in the relay to avoid issues related to unwanted changes in the settings. So again, if the automation engineer need to, I mean, in case automation engineer need to change the settings, then they need to work with protection engineers, and then they can change the settings in case any changes required at the automation part. Next part is a communication system. So each relay, again, it can communicate with the communication network or centralized location or centralized systems through the port, different ports. So internet. One thing is that the relay has internet access. Each substation device. This is a relay, protection relay, maybe an overcurrent relay or something, and then it can access through the internet. That is one thing. So if you connect the computer to it's one of the port, then just by opening a web browser, like the computer can communicate with the relay. So even the setting changes can be done just from the web browser softwares. I mean, there's no need of any sophisticated software to change or control the setting. Just with the web browser software, the relays can be controlled, okay, or maybe the changes can be done in the setting. So unique internet address for each device is is there. That is how it can be controlled. Web browser software can be used to communicate with the device. This part is what we discussed just now. So what are the precautions in terms of cyber security? Requirement is that disable setting changes from web browser, because there are sophisticated software to do that setting changes. So why we need to uh, um, give the privileges to change the settings on web browser? It's not really required. So by just disabling, so the relay has a feature to disable the setting changes from the web browser. So that need to be done. So otherwise, if somebody comes at the substation and they can communicate to the relay through a web browser software, they can even change the settings. So that should not be given permission. So what is the cyber security related precaution is that disable the setting changes from the web browser. Unused port in the relay can be disabled. Again, you can see the port here, right? RS-232 port, or maybe this is optic fiber port, and this is some Ethernet port. You can see this part, and in the front of the relay also there can be some port like this. So in reality, maybe only the Ethernet port or maybe this fiber optic port will be utilized to communicate with the relay. So other port is just spare; it's not utilized. So the requirement is that, or the cyber security requirement is that this unused port need to be disabled. So nobody can come and connect an unused port and try to change the settings. So unused port need to be disabled. That's another precaution with respect to cyber security. Because let's assume that this RJ45 or maybe this Ethernet port is connected to the SCADA system to monitor or control this device. So this is already connected. So this fiber optic port or maybe this RS-232 port or this iRigby port for iRigby port is only for synchronization, time synchronization. So other port can be used for setting changes also. So if somebody comes and connect any of this port, they can change it. But one can ask a question like, okay, they can come and change this. I think remove this SCADA port and connect their port into that, and they can control it. Yes, yes, that's the possibility. But whenever any unused port is disconnected, immediately the SCADA system gets an alarm. Okay, there is a issue in the communication network. There is some break in the communication network. So that alarm is available. So anybody can check is there any issue, and also it gets a second alarm that okay, there is a change in the setting. So maybe the operator or the protection staff can sense that there is something really wrong at the relay, so they can either either they can go there, or maybe they can disable the relay, or they can take some outage in that circuit and go and go to that relay and make some like they can check that is there anything wrong there, or somebody has entered into the substation. They can check that camera information and all that, so that's possible. uh, Another precaution is that components in the network, such as switches, routers, firewall, shall have their own security, to avoid unauthorized access. IP filtering is another thing, like which or equipment can be connected to the network. That's a part of IP filtering. So any new IP equipment with any new IPs will not be cannot have any access to the network. Encryption, again, encryption can be used on the LAN to secure traffic against unauthorized access. This can be also done in routers, firewalls, and some IEDs. So these are the precautions with respect to the cyber security when we talk about relays for automation, protection, and control. The relay pilot channel, we have talked about it, like what are the importance of communication system in the case of protecting the transmission line. So definitely there should be communication link between the relays, that we have seen the requirement of that. But generally this communication will be connected from one relay to another relay. It will not be taken, even though it can communicate with a normal network to this one, but generally we don't do it. Generally the communication will be uh, from relay to relay. One fiber optic connection will be done from one relay to another relay, not take the public network for communicating this current and voltage information back to the other end relay. So this predominantly operated on private and closed network. But still, if attackers access this communication channel, what could happen is that there are two possibilities. One is denial of service. It's like making a break in the normal transmission of real-time protection messages. Like earlier we have talked about direct transfer tripping. Like whenever zone 1 operated at one end, it's going to issue a command to the other end, then other end also operates immediately. So but when this breaks, this communication channel breaks, what happens is that cause a break in the normal transmission of real-time protection messages. Second part is traffic manipulation. Somebody enters into this network, and then they can manipulate the data goes through it. So maybe without any fault in substation side B, without any operation of zone 1, it just issues a command. If they enters into this communication network, they just issues a command back to the other end. Okay, okay, there is a tripping other end, but actually there was not tripping at other end, but some nuisance information or wrong information is transferred to the substation and A relay, saying that okay, there is a zone 1 operation from the other end, so this is going to trip immediately. So that's a traffic manipulation. So you can see like what could happen. So denial of service is one thing, that is a break. So denial of service is something like there will not be any tripping. Like even if zone 1 trips here, if there is a break here, the signal cannot reach to this point, so this end will not be tripped immediately. But in the case of traffic manipulation, what could happen is that without any tripping here, this end can be tripped just by sending a signal from the manipulation part. I mean, traffic manipulation part. Then they send a signal back to this end, and then it can go for false tripping. So that is with respect to DTT, direct transfer tripping scheme, which we have discussed Other schemes are there. I'm not going into the detail of other schemes. Again, there are effects for the denial of service and traffic manipulation. So, what are the threats and vulnerabilities? What are the reasons for cyber attacks? Okay, one is job dissatisfaction. So, somebody is not happy with his job because most of the time, cyber security attack happens with knowledge of some employees because they are not satisfied with their job, so they wanted to make a harm to their utility or something. So that's the one thing. Economic gain is another thing. So some parties may be working to get some economic gain from some extremist agencies or something like that. So that is another thing. Competitor discrediting. So maybe one manufacturer want to discredit the product from its competitor. Maybe they are attacking on one particular manufacturer, so that the utilities will not have faith on that particular product. So the manufacturer who was actually attacking can have a better market or better business. So that's another thing. Job security is one thing, but this is basically what it does is that maybe one person is doubting his security of the job, so he might do like he put some passwords in all the systems. Okay, so that he only knows about the password. So in case any setting changes is required, or maybe say any maintenance requirement comes, then only he can do it. Others if try to access it, it's not accessible, but this fellow only can do it. So he thinks that okay, this is because of this his job is secured, but in reality that may not be going to happen, because if some of the system is not accessible, definitely the management will try to understand like what is the reason for that. So maybe if the management finds that okay, this guy is creating the issues and maybe his job may not be secure, he may be terminated immediately. But there are chances or there are some incidents reported in this way also. There are some threats reported this way also. Blackmailing is another thing, or the terrorism or political reasons are another reasons for cyber threats. So what are the vulnerabilities? Yeah, which are the system vulnerable to cybersecurity attacks? So one thing is that security gaps in the computer software itself. So some computer software is not secured enough, so the attackers can come through that. So probably some of the cases can be like some user convenience features are available, so that is being utilized from some user. Maybe automated execution of attachments, or maybe yeah, attachments in email, or download programs, automatically download the programs or script in the email. So probably somebody keep some settings like that, so that can cause a problem. So some of the script or programs may be vulnerable to cyber security, cyber attacks. So unknowingly that can cause a problem. So this kind of user convenience features, uh, it should be careful. The user should be careful with the user convenience features. Then incorrect configuration of incorrect configuration of security permissions and privileges. This is another thing. So factory default setting are still used. Did not change the settings with respect to the place at which at that point, like what are the security features should be there or privileges should be given, so that need to be taken. So factory default setting need to be changed. So that those are the vulnerabilities with respect to the security gaps in computer software. Another thing is that maybe some of the software manufacturer built some proper. They built some vulnerabilities in their proprietary software for contract enforcement purpose. Maybe some of the software is given only 1 year of time, immediately after that, software has to be disabled. So the software manufacturer makes some techniques, kind of they make some backdoor built into software to prevent use after the alleged violation of contract terms. Like if the user violates the contract terms, so they wanted to block the software or something like that. So they make some backdoor entry without the knowledge of the user. So that may be used by the attackers also sometimes. So if they knows about it, they can use that part, backdoor entry part, which is done by the software developer to enforce the contract terms and conditions. So that is another thing. The vulnerability related to the communication links and networking software. Again, it's like hijacking, like maybe takeover of a user session after authentication. Like when user is authenticated into the system with password, the then somehow the attackers hijacking that system, and then they can do whatever privileges this particular user has in the system. So that is one thing. Then breaking of encryption route is another thing. Then denial of service attacks, that is also another part related to the communication network. So maybe the attackers will try to prevent the normal usage by causing extreme network congestion. Basically, like they send some data in the communication networks to have a congestion in the network, so the normal use of communication network can be avoided. So that's another vulnerability. The system administrator issues, yeah, account and access control setup is normally done by the system administrator. They do some mistake in that, maybe the software installation removal privileges should be given to only very few people, maybe related to the system administration department. So by mistake or something, that is given to some of the users, so they can install some softwares or remove some software. So that can cause an issue. So system administrator issues are related to that. Vulnerabilities based on user personal. Again, some of the user doesn't want to make any password, so they're happy with no passwords, or maybe setting some password which is same as user ID, or again using some password which can be easily guessed by other people. So these are some of the things which is related to the user person. And also some phone call or some marketing calls or comes marketing survey calls comes, and they ask for some critical information, even some password information they are asking. So some of the users may not be aware fully about the consequences of giving such information, so they may give it. So these are the vulnerabilities based on the user personnel. Other vulnerabilities may be kind of virus or Trojan, something like that. They're attacking the network and getting into the systems. So that's another thing. These are the communication protocols mainly used for grid, I mean utility level. IEC 60870-5, DNP IEC 6087 0-6. Right now, mostly IEC 61850 is being used because of it can be adopted for many things. It can be used for substation automation, distribution automation, power quality, distribution energy resources. So it can be used for different functionalities. So this is the popular communication protocol, or this is mostly used communication protocol right now. These are the cybersecurity standards, some of them from IEC 62351, C37240, NERC standard is also there. And,
Sir Vinod sir, could you please mute yourself? So sorry sir, sorry for the interruption. You can continue, sir.
no problem. Okay, so there are some cybersecurity initiatives in India also. We have some national critical information infrastructure protection center. They develop the guidelines for protection of critical infrastructure. Basically, the critical infrastructure includes utility also. So guidelines are available, and there is some computer emergency response team set is available. Region wise is also is available. So all the utilities is it's mandatory to inform to this agency, computer emergency response team, if there is any cyber attacks observed. If there is any cyber attacks observed, immediately the utilities should inform or shall inform the this team, cyber emergencies response team, so they can give alert to the similar parties, maybe utilities, to like they can actually control the spread of that virus. So it's mandated. It is mandatory to give this information to this team. That's really important. So these are the cybersecurity initiatives in India. Some of them. And what are the cybersecurity threats and vulnerabilities, which we talked about in the previous slide, like how employees can make problem related to this. These are the mitigation, some of the mitigation steps. Uh, Password and key management. Okay, the utilities should give guidance in selecting password parameters based on increasing security requirements. Then they should give some guidelines on characters in the password, length of password, lifetime ownership, all these things. So ownership, basically, like password should be owned individually. It should not be given to a group. Okay, that's important thing related to the ownership of the password. The storage of password in the authentication system. That's also one of the concern. Like sometimes this password is stored in the authentication system. So whenever we enter into the PC, then all the systems are already authenticated. So that's also can create an issue. So somebody steals this login information of the system, then all other related systems are already authenticated. So that's another concern. The entry of the password is, yes, like observer, maybe who is standing close to the employee can see, like observer can see the password. That is other thing. So maybe somehow we need to ensure that nobody is watching when we enter the password. So that's another thing. The maximum number of incorrect entry need to be specified. So somebody try to steal the password by putting more and more like trying different passwords, so that need to be controlled. And also alarm has to be generated in the system, and authentication period also to be defined, like once password is entered into the system and the person is idle for a time, maybe 5 minutes or 10 minutes of time. So based on criticality of the process, the authentication period need to be defined, maybe 1 minute or maybe 5 minutes or something like that. Then procedural security, like it's again monitoring and controlling of network and IED. So uh, the network monitoring means detecting network failures, detecting status of backup or spare equipments, detecting uh, like denial of service attacks or something like that. Maybe if there is an overflow of data in this communication network, these things need to be detected on a continuous basis. Again, detecting this invalid network access, and always have a log for each and every activities by the system itself. There is a procedural security. Always monitor what is happening in the system, and maybe in case some controlling also need to be done, maybe switching off or switching on of some of the devices also need to be done. So that's the thing, procedural security. So the status of the communication network need to be known all the time. So LAN and IP security is another thing. So sometimes the employees stick their password on the computer monitor or leave the PC unlocked. Both are really dangerous. So some attackers can enter into the system, and then they can do for, I mean, in the system where this particular employee has the privilege to do that. Then some employees like bypass the controls and turn off the security measures. So these are the issues related to this LAN and IP security. Configuration change control management. So again, this has to be done by the authorized person only. This privilege should not be extended to the each and every employee. Extend to each and every employee. Only should be available with maybe mostly the system administrator, or maybe the system administration team. Only with them, the control or configuration change should be possible. It should not be given to some third party or some other non-related employees also. The protection of IED maintenance port, which we talked about it, like the port, the communication port in the IEDs should be the spare port should be disabled, or maybe the ports which is utilized should be monitored well. So that's another part of it. Physical security is again fencing or other thing, or CCTV cameras and other things. So that part related to that. Remote access, nowadays the remote access is possible through PCs or even through mobile. So should be very clear, like who is getting access and other things need to be very clearly known. Again, intrusion detection systems can be utilized as a mitigation step. Recovery or remedial from a cyber attacks is another things. For that, need to know like who has attacked, for what reason, where the attack was happened, when it happened, and why. So all these questions should have a proper answers. Then the remedial action will be much faster. Then physical security, we talked about it, fencing, gates, limiting access to authorized persons only by having smart lock or access card systems. Access control measures should be like identify, and there should be a process for all visitors like vendors, contractors, and alarm systems to monitors the entry to substation grounds, perimeter alarms, CCTV and guards, vehicle barriers, adequate lighting, signage, and there should be comprehensive security awareness programs to its employees. That's also really important. The mitigation action items is we talked about it, but this is a step, or the list of what it is. One thing is that establish a broad corporate security policy based on its recommendation tailored to the needs of protection relay system. Basically, come up with a policy related to it, and access the existing communication channels for vulnerabilities to intrusion. Basically, it assess the communication network, what is the status of it. Implement and enforce policies, like whatever policies they brought in, that need to be enforced into it. And monitor logs, this is very important. Always see what is happening in the system, monitor all the logs, and monitor the traffic also, who is getting access, who is taking more and more data. All this need to be monitored. Maintain and monitor list of authorized personnel. This is another things. Sometimes, I mean, this is a dynamic list always. If you take the case of a utility, it's a dynamic list of authorized personnel. Some person goes to another department, whatever privileges he had need to be removed. So this has to be maintained properly, and it's a dynamic list need to be maintained properly. So I come to a conclusion of my presentation. So as we discussed, the protection and securing of networked communication, intelligent equipment, and data is vital to the operation of energy system. It's really important. We know that without this communication system, the present and future energy system cannot be monitored and controlled. It's almost impossible. So it's a requirement. Network communication and intelligent equipment is a requirement. So development of a security policy and its strict implementation will reduce the cybersecurity events that lead to interruption or disruption of services. It's really important. At a utility level, the security policy need to be developed, and they should do the strict implementation of this. So that will reduce the cybersecurity events, which can lead to disruption of service. So I came to an end of my presentation. So if there is any queries, I can try to answer those.
Participants, if you have any doubts, you can ask. Sir, on behalf of our management, our principal, and our HODs, I would like to extend my heartfelt thanks for accepting our invitation and delivering the lecture on cybersecurity aspects of smart grid. So the session was highly informative, and I am sure the participants would have been highly benefited. Thank you, sir. Thank you once again for accepting our invitation and delivering the lecture. Thank you so much, sir.
Thank you, sir, and thank you very much for inviting me to this event. And thank you very much for the management of St. Joseph Institute of Technology, Triple Department, organizing committee, and all the attendees for the patient hearing of my session. Thank you very much, all.
Thank you so much, sir.